Hello, my name is James, and in this video we're going to talk about modifying a laser printer to use for toner transfers. Toner transfers are when you take the copy that you made and you move the toner that was on the print and you stick it to something else. This process can be done chemically, where you take a laser print and you use a solvent such as lacquer thinner, and then transfer it, soften the powder that's on the page and then transfer it that way. But if you're going to be doing it with ceramics, or if you need it to be particularly thick, what comes out of a normal laser printer is fused to the paper. And so the powder that's distributed by the printer is then fed through the fuser, which is a hot roller, and it melts the powder to the page. Now, usually that's what you want in a print, but in the case of, if you're trying to use it for an artistic purpose, it's really nice to have it set so that it doesn't do that. So we can trick the printer into doing that. This particular printer, the Canon PC170, popular with ceramicists because it has a high enough iron content in the toner to the iron oxide will then, after you fire it, go stay dark. Some of the other toners are either plastic-based or something else where it just burns away. But I have previously modified this one with a potentiometer here, tuned to tell the fuser that it's already up to temperature. And so when we make our scan, instead of being hot, the temperature sensor thinks it's already hot, so it doesn't heat it up. And so our print is just powder on the page. And so if you have something you want to transfer that to, such as a piece of clay, you can then get the image on the clay and then that will fire with the image on there. Now, I would imagine you want something a little more complicated than that, because this you could probably do by hand separately. But for an example, I hope you get this. So, the way we're going to do this is, first off, unplug the machine. Oh, well, let's talk about what the rollers look like, because you're not going to be able to see it very well in this machine. This is a fuser cartridge from another printer, and your heated roller is up here. You've got two sets of wires to it. You've got one set of heavy wires. This is to power the heating element, which oftentimes is just a light bulb. This is a heating element to get that roller nice and hot enough to melt the toner onto the page. And how it knows how hot is the second wire right here. There's this little wire. This is your temperature sensor, and it has this little feeler that comes out and touches the roller here. I'm going to pull it out for you. Normally they're screwed down. This is what's called a thermistor, and what it does is that it changes its electrical resistance depending on how hot it is. So what I did is I got one of these, I got this running, and then when it got up to temperature, I quickly unplugged it and then tested the resistance between these 2 points, or you could find anywhere along the wire. And instead of being nearly infinite resistance, instead of being, having no ability to pass electricity through it at all, it had somewhere in the vicinity of 9,000 ohms. And so then I was just able to take a trimmable potentiometer. There's lots of different ways that they look. This one is just a basic dial with 3 leads coming out of it. And so the idea is if you can add another element here in between these two things, it will let electricity pass through here, through this wire system, and tell the printer that it's already up to temperature even when it's not. So that's the gist, that's the theory of what we're doing here. A good first step whenever you're working on stuff like this is unplug it. 120 volts hertz. If you're from England, that's 240 volts, and that I actually would not want anyone to have to experience. We're going to have to take this particular model apart. It's fairly simple. You just open up the back, find the fuser. If it has a replaceable fuser, you can just pull the fuser out and do the modifications that we're about to do just to this wire here without having to get into it. Unfortunately, the Canon PC170 requires a little more getting into. And so I'm going to go around and I'm going to take all the screws out of this. I'm going to put them safely in my little catch tray. If I'm ever nervous about getting the right screws into the right place, I'll draw a picture of the device I'm taking apart, and I'll tape the screws to the piece of paper in the locations that it goes. As you remove this, note that you're picking up a piece of glass here, and that it's hooked under a tab right here. When you put it back, you want to make sure that you get the glass underneath that tab, or else everything's going to be terribly out of focus, and you're going to wonder why. Ask me how I know. All right, so I'm going to put this up here. Even though this is unplugged, it is possible for there to be capacitors in this, in any electronics that you take apart. The safest thing to do is to unplug it, turn it off, and then wait 30 minutes. It is possible for there still to be a charge left over, like having a battery in there, that can zap you. In some devices, this is incredibly dangerous, like old televisions. It's famous for killing people. This particular unit does not have that kind of power, but just keep that in mind when you're tinkering with stuff. So what I'm going to do is I'm going to try and get this back cover off here. And I did this a while ago. Yeah, by taking these 2 screws off, that loosens this here. There's still something holding on back here, which could just be clipped, or we could be missing a screw. So I'm going to come back around, give it a wiggle, and I'm going to see where we might be missing. So that one comes off. Okay, so forgot to take the little clips out here, which allowed this to open up all the way, which then allows this to come up. But then the crux of it is this tab right here. You get a flashlight and you look in this corner, you can see this tab hooked over a thing and it won't come out till you get that. The rest of these, you just kind of come in and lever outwards. But none of it will come out unless you take those clips from the ends here on the either end of that hinge. Okay, so now that we get it where we can see it, what I did was I just took this potentiometer, or adjustable resistor, is what it is, and I unplugged the temperature sensor from the thermistor here, or I unplugged the cable to the temperature sensor, which is in this back corner over here, and then plugged it into this, which was pretending to be the temperature resistor. Now what I'm going to do is, so that this could be used in either way, so it's not permanently adjusted to that, is I am going to add a switch so that we can just turn that on and off as needed from the front, whether it wants to be a transfer printer or a normal copy machine. All right, so I will get out my soldering supplies, and what I'm going to do is just very simply here I've got wire coming in that has a plug. The plug goes to wires, plug, thermistor. I'm going to actually not going to disconnect the wires here. What I'm going to do is I'm going to just add in this resistor here, because this one's at such a lower value than this one that it's not going to be noticeable at all. And then the switch will just be to turn on and off whether this one's attached. So this one never gets disconnected. And then the switch will just turn on whether or not this one's connected. So the switch will be right here, turning, cutting this leg or not. I'm going to pause that for now. Okay, so got my soldering station sorted out. And this is kind of the scary part, because cutting stuff is, feels permanent. But you can always uncut stuff. All right, so these are just some cheap Amazon auto wire strippers. I'm going to take just a tiny bit off the ends. Go. Off the ends there, a little bit off the ends there. It's important to note that the thermistors are not polarized. Doesn't matter which way you send it. Should be the same either direction. So we have those set up. That's set up. Next thing I'm going to do is I'm going to use a little bit of shrink tubing, because I want this to be able to be carried around without anything falling apart. If you're not familiar with soldering or shrink tubing, we'll have to do another video on that later. Alright, so now what I'm going to do is I'm going to tin all my wires. Basically that's just getting solder on ahead of time so I don't have to fiddle with all the bits at once. Okay. So one of these legs ultimately I'm going to solder these, the yellow and blue leg back to the yellow and blue leg. But instead of just being the yellow and blue leg, it's going to be, instead of just the blue to the blue, it's blue to the blue in the switch leg. And instead of yellow, it's going to be blue to the blue, or yellow to yellow, and the potentiometer leg. Alright, so we've got that one in there. If you don't have a multimeter, again with a multimeter, what I did is after I connected the temperature sensor to the potentiometer, I turned the machine on and dialed it slowly until it started to work, basically, until it said, oh yeah, that's the right temperature. I did this on one printer where you could actually see the light from the heating element. And I was able to just dial it back and forth until the light flickered out, which told me that it thought that was enough heat. All right. So now we should be able to plug it all back together. This piece came off of the end of the heater. I think it's going to be easier to plug this in here first, and then plug this back on the heater rather than trying to figure out how the tiny little piece clips in. Move the wires just a hair shorter in doing this. So we'll find out if I'm going to have to go back and use extension wires. I think I'm going to be okay though. Make sure my wires aren't interfering with mechanical functions. And then last but not least, let's figure out where I want this switch to be. I think I decided earlier that I wanted it in this front cover where it would be protected from this protruding face right here. So right about, looks like it's going to fit right there just fine. Never use power tools without safety glasses, ever. Okay. Okay. That's good. And so now we are going to give this a try. Now most machines won't fire up if you don't have the cover on. There's usually safety switches someplace or another. So I'm going to go ahead and pop the cover back on. Rotate that to the left. Pull. Oh, that's that piece there. This one isn't in there yet. Okay, so this has to be straight up and down. Which of course means that wants to slide up because I've got the table slanted. I do not know how people do videos and still make it look easy. It's hard enough doing the thing sometimes. Alright. Stop that. Alright, so now that can come down. That snaps in place. That snaps in place. Just press it on. Yes. Yes. Looks like all the buttons are lined up. You're going to click on that. Oh, because that's the switch. That's the on switch. All right. And then close that. Brave. Usually I test it before I put it all the way back together, but I have a little faith. Tabs. Some tabs. Okay. Screw. And these plastic bits that were keeping me from opening it. Sometimes it takes just a little bit of massaging to make sure everything's popped back into place. And the ever so critical glass under the tab. There we go. And slide this side to side to line up pins and screws. Probably can't see that. That style is where the plastic is. That threads into plastic. And then it's got much, much finer threads if it's going to thread into metal. Generally speaking. To turn off the soldering iron. Not anymore. Okay. So we put our original in. Ever so original. Get a sheet of paper. Turn the machine on. Plug it in. Turn the machine on. And let's see where we are. So in this mode, we're still in doing transfers. And hopefully, if I flip that switch, that will cut out our modification. And we'll start to heat this and act as a fuser again. And there we are. Happy hacking.